So we're going to take a look at an RC circuit, and to start with, I've got a function generator that I'm going to wire up connected across a capacitor and then a resistor. So this is our basic circuit, and the function generator here can output a sine wave at varying frequencies. To measure, I'm going to hook up an oscilloscope so that channel 1 will be looking at the voltage difference across the series combination of the capacitor and the resistor. And then channel 2 will be looking at just the voltage across the resistor. So that will tell us the current in the circuit. So here's our circuit all wired up and the instruments. The output of the function generator down here is on, let's see, this cable connected to the capacitor. It goes out along this blue wire into the resistor here, and then uses this blue wire to come back to the other side of the alligator clip. That's the core circuit, and then the oscilloscope channel 1 you can see is wired to the same place basically. Channel 2 of the oscilloscope is just looking at the voltage across the resistor here. So on the screen here, the upper trace, as you can see, the little 1 there, that's channel 1. Channel 2 is the lower trace. So this is the voltage across the function generator or the series combination of the capacitor and resistor, and then channel 2 is the voltage across just the resistor. So you can see there's almost no voltage across the resistor right now. If I start turning up the frequency, you can see the amplitude of the current starts to increase. The voltage across the resistor is starting to show up. And if I go to really high frequency, the amplitude gets comparable. Again, change the time scale so we can keep track of the waveform. But now you can see a high frequency. The voltage across the resistor is almost the same as the voltage across this circuit. You can see that's the function generator output, and that's the resistor voltage. So these get to be pretty close. That means there's only a small voltage across the capacitor. So the effective impedance of the capacitor is small at high frequency like this. Go back down to low frequency, and you can see right around here, around 5 or 6, 700 hertz is where a lot of the change happens. If I go up to, watching the frequency here, if I go up to 2, 3 kilohertz, the voltage on channel 2, so the resistor, it's almost the same as the voltage across channel 1 or the whole circuit. At a low frequency, you can see there's much less voltage across the resistor than across the series combination. So here, at low frequency, 230 hertz, the capacitor has quite a bit of voltage across it. So while I'm here, I'm going to show you the other measurements. So here I can see the frequency. This is measuring channel 1, so the function generator. This is the frequency determination, the voltage, and the voltage for channel 2. In order to measure the phase shift, you can see this signal is a little bit ahead of this one by less than, it's less than a quarter cycle, but this peaks first and then that peaks. So the way to measure that is I'm going to switch to the cursor page, turn type to time. So I have 2 time cursors. I'll go ahead and zoom in. I'm going to turn this amplitude down just to get the peaks on screen. And now what I can do is line up cursor 1 on the peak of channel 1, cursor 2 on the peak of channel 2, and there you can see the important part is the delta. That's the time difference between the 2 cursor positions, and here that's 188 microseconds. So that's the delta that would go on the spreadsheet, and then we'll use to calculate the phase difference.